So let's start doing the BFS traversal in a graph. So basically the question is pretty simple. We need to traverse the whole graph starting from 0 in such an order, basically in the level wise order. So here we can see that if this is our given graph, so the level wise traversal would be 0. Just a second. Okay, so the level wise traversal will be 0 first, then 1, 2, then 4, 5, 3, 7, then it will be 8 and 6. So, to do this BFS traversal inside a graph, we basically need two things. First is a queue. We need a queue to store the level wise order and a visited array so that we don't visit the same thing again. Okay, so the basic approach will be that first we will simply store this node inside the queue, and then we will uh, we will try to go on the adjacent nodes of 0. So they will be 1 and 2. Now we will reach 1 and then we will again add it to our queue. So assume that first we have added this 0 here, okay, in the initial traversal. Okay, so 0 is already added here. Then we basically traverse the whole graph, and now we poll this value. So we poll the node, so we will get, we poll the- so the node we will get is 0. Okay, so now we will check if 0 is already visited or not. As we have added it in the queue, so it will already be visited. Okay, so now this is visited. Now we will check for its neighbors. So its neighbor are 1 and 2. Now we will add 1 and 2 to the queue. So 1 is added here and 2 is added here. Remember that queue has been polled, so it's no longer there in the queue. Okay, so 1 and 2 are again there in our queue. Uh, when we pulled out the queue, 0 here from the queue, we simultaneously added it into our BFS array. Suppose that this is basically my, okay, suppose that this is my BFS array or array list, we can say it. Okay, so here the 0 has been already added because we have done our calculations on it. Now in the next we have 1. Now we pulled out 1, so now the current node is basically 1. Now uh, as we are working on 1, so we will mark it as true. Okay, and we will add it into our original BFS array. Okay, now we will check if its neighbors are visited or not. So we can see that 4 and 5 are not visited, although 0 is also its neighbor, but we are not considering it because 1 is already marked as true. That's why we will use a while loop here, or we can say simple if loop here to check that we are considering the adjacent element which is basically not visited yet. So 0 is visited, we will not consider it, and 4 and 5, these are not visited, so we will consider it. Now 4 and 5 we will mark it as true and we will add it into our array, into our queue. So 4 is there now and 5 is also there, and 4 and 5 are marked true as well. While adding it to the queue, we marked it as true also in the visited array. One has already basically been calculated, so we remove it from our queue. Now what is the next number in the queue? It's 2. So now the current node that we are working on is basically 2. Okay, so 2, it was already there in the queue, so it was already marked as true. Now we will check for the neighbors of 2. So again 2 has 3 neighbors, that is 0, 3 and 7. Now 0 has already been marked true, so we will not do anything for it. Now the other neighbors are 3 and 7. 3 and 7. These are not already marked as true. Basically it is false. Okay, so now we will mark them as true. 3 uh, and 7 as well. And while marking them, we will also add them into our queue. So now we will add 3, just a second, 3 and 7 also. Okay, so the work of 2 is done now. Now we will be working on 4. So now the current node is basically 4. Okay, so 4 has basically two nodes, two neighbors, that is 1 and 8. 1 is already marked true, so we will not be working on it. Now we come to 8. 8 was previously false, so we will start working on it, and for that we will mark 8 as true. Now 8 has been marked as true, so we will add it into our queue. And sorry, I forgot to basically whenever we finish the poll task of the of this array, we add it into our BFS traversal. BFS. Okay, so 0, 1, 2, then 4, because the task of 4 has been done now. Whenever we go to its neighbors, we basically add that to our BFS array list. Okay, so 4 is done. Now we will move to what, 5. So 5, now the current node is 5. Whenever we see this, now we call for its adjacent neighbors, but its adjacent neighbors are 1, just 1, and 1 is already visited. It means that the task of 5 has been done, so we add it to our BFS array. Okay, now we come to 3. So 3, current node is basically now 3. Now we can see that 3 has two neighbors, 2 and 6. 2 is already visited. Whenever we pull this out, we simultaneously add it to our BFS array. So 3 has been added here. Now we can see that the neighbors of 3 is 2 and 6. 2 is already visited, so we would not do anything. And 6 was previously false. It means we have to work on it. So we mark it as true and we add it to our queue. Now 3 is done. Now we have the next node as 7. So we are working on 7. Now we can see that 7, whenever we took out this node, we simultaneously added it to our BFS array. Okay. Now 7 has only one neighbor, that is 2, which is already visited. So we would not do anything and we will simply move to the next node, that is 8. Okay. Now 8, whenever we pulled it out, we simultaneously added it to our BFS traversal. So the task of 8 is done because it has only one neighbor that is already visited. Simultaneously for similarly for 6. 6 is also already the neighbors of 6 are already visited. Okay. So this is how the BFS traversal works. We can see that the BFS order will be 0, 1, 2, 4, 5, 3, 7, 8, 6. 0, 1, 2, 4, 5, 3, 7, 8, 6. Okay, so the code is here. Basically, we create a queue to store the level wise order traversal. Then we have this BFS array that we will return at the end. Then we have this boolean visited array of size v, where v is basically the number of vertices. Now, first of all, we add the first element to the queue. So the first element of the given array is 0. So we add 0 to the queue and we mark it as true. Whenever we add something to the queue, we mark it as visited. Then we go inside the queue and check for whenever the queue is not empty. Just remember that we have created this integer, this capital I integer. So we will not use again the small int. again, and we will use the integer throughout the program. Okay, so we pull out a node from the queue, and then we add it to the BFS traversal array. Now we check for its neighbors for the current node. For example, if I am working right now on 0, so 0 is my node, and I will check its adjacent neighbors, that will be 1, 2, and 3. Now I want to add them into the queue. Okay, but I will only add them into the queue if and only if they are not already visited. So I will have this check here. If the visited of I is false, then I will mark it as true and I will add it into the queue, and then at the end we will simply return the BFS traversal.